In this lesson, we're going to take a quick look at what we're building in this course. So this course is based on a rapid gravity sand filter, and what that does is take in dirty water, pass it through sand or a medium, and then pass it out of an outlet valve at the end as cleaned water. What we're going to be controlling is the process valves and some instrumentation, flow meters, stuff like that, that actually makes up this sand filter. So there's going to be various states which we can see down here in the bottom left. This one is offline, and we're bringing in our unfiltered water up here. So let's just go through the individual assets. We've got our inlet valve, backwash valve, which is used for cleaning, our outlet valve, which is where our post-filtered water goes. We have an air scour valve, which agitates the media as part of the cleaning process. We have a waste drain to remove any dirty water as part of the cleaning process, and a rinse valve, which is also part of the cleaning process to help remove some of the water that ends up underneath the filtration media following a clean. We then also have some instrumentation, so our filter level up here, a differential pressure, which is detecting the blocking of the filtration media. We have a turbidity monitor on the outlet valve, and we also have a flow meter on the outlet valve, and we have a turbidity monitor on the waste drain, and also a flow meter on the waste drain. And together, all of these assets come together to create the control procedure for this sand filter. What we're looking at now is offline mode, what we'd expect the filter to be in, the state we'd expect the filter to be in an offline situation. So right now there's no water in it at all, but there's also no valves open. So under the offline state, there's nothing happening with this filter. In the filtration state, we have an inlet valve open, passing unfiltered water into the filter. And we also have the outlet valve open. And there's other requirements that aren't pictured here, such as monitoring of the level, the position of the outlet valve may not be 100% because we're trying to achieve a flow target and also stop the level from falling too low or getting too high. And then we also have a turbidity monitor that's checking the actual cleaning process of the filtration media and how much bacteria or dirt that's taking out of the unfiltered water. We then have wash conditions. So as I mentioned earlier, we have our differential pressure, which causes a wash condition if the differential pressure gets too high, a turbidity monitor on the outlet, which if the turbidity gets too high, we cause we call for a wash as well. And then also time. If neither the differential pressure or the turbidity monitor call for a wash after a particular amount of time that's settable, we then call a wash anyway, just as a belt and braces approach. So as part of the washing procedure, we have a rapid drain down. And what that entails is opening the washout valve after closing the inlet valve, so there's no new water going into the system, and we open the washout valve to drain the system right the way down to this weir level here. And that basically just dumps all of the unfiltered water straight out of the system to get us to a designated wash level, which is at the top of this weir point here, ready for the wash procedure. So the first thing that happens is the air scour valve is opened, and notice that the washout valve stays open the entire time. So the air scour valve is opened, and we force air into the filtration media, which agitates the sand or the filtration media to allow for an effective clean later. And once that's done, we then come into our backwash. So we open our backwash valve again, leaving the washout valve open. And that forces clean water the reverse way through the filtration media and washes the dirt that's accumulated in that filtration media out over the weir and through the washout valve. So there are some other conditions regarding the flow meter, outlet valve position, and turbidity monitor that are in effect during a clean, because the last thing we want to do is to allow this dirty water to get out of the outlet valve. Even if it was just backwash water supply, that may not necessarily be treated water to an effective standard to be allowed out of the outlet valve. So we will be making sure as well that these instruments here and the position of the valve are safe for this backwash to occur. Once that we've flushed or backwashed the filtration media for long enough, we then move on to the next step, which is the top wash. So we open the inlet valve and allow the inlet water to run across the top of the filtration media, pushing any remaining backwash water that's passed reverse through the filtration media out and through the washout valve. So what we should be left with at the end of this stage is filtration media backwashed and cleaned, and any residue left on top of the filtration media replaced with unfiltered water that would be safe to pass back through the filtration media. If this step wasn't done, we'd end up with dirty water that's just come out of the filtration media being put straight back onto the media, so we'd have an ineffective clean. Once that's finished, we then do a media rinse. So we then open the rinse valve and close the waste drain, which forces unfiltered water to go through the filtration media, but rather than go through the outlet valve, we pass it through the rinse valve, which ends up in the drain as well. But there's additional instrumentation for the flow meter and turbidity monitor. And what we do is we check within a period of time and with adequate flow, is our turbidity coming down to an acceptable level to open the outlet valve? Because if we didn't do this step, then although we've been back flushing the filtration media for long enough, there's still a risk that reversing the flow again and coming down through the filtration media would pick up any residue that hasn't successfully been backwashed out, and that goes straight out the outlet valve. It also replaces the backwash water underneath the filtration media with eventually clean filtered water once we've detected that on the turbidity monitor. And after that, we then drop back into normal operation, where we open our outlet valve and continue the normal operational process of monitoring for wash conditions or failures. So part of this setup will be looking at this from an asset point of view. So we've touched on this in the what's in this course video as well. So we'll be looking at asset objects such as our analog instrument, quarter turn valve, and modulating valve for our outlets. And on top of that, we'll also have some control objects such as our SCADA interface for when we go ahead and build our SCADA environment, and any filter interlocks that are required to shut the filter down, and various other control management objects that may come from third-party systems or from a supervisory system. So with a wider respect to how this comes together, we'll be looking at a hierarchical approach to this, where we include things such as a base analog asset, convert that to a level asset which encompasses the base analog asset, and that would be something like our filter level. And then we'd also have a base analog asset here, which would become our differential pressure, and the same for all of our instrument assets, where varying them when required for their specific needs. So we can see here that the differential pressure, turbidity meters, and modulating valve feedback do not need any special requirements against our base analog asset, but our flow meters and level assets, they do. So we'll go through that as we build the system. So for example, we have our analog instruments here, and we're looking at our analog assets. We'll have 4 to 20 milliamps, 4 to 20 milliamps going into different asset types, but we also want to build in capability for things such as 0 to 20 milliamps and 0 to 10 volts. And we'll have a look at exploring how we achieve that flexibility while still having a rigid analog asset structure. And for what we're going to do in this course, that pretty much covers everything. There is a lot to this course. The course is designed to take everything step by step, with theory modules before and then practical examples after, and all of the project documentation, programs and examples will all be freely available to download at the end of that section of the course.